Assalamualaikum and hello to those who are watching these videos. My name is Ahmad Syakir bin Muhammad Khidzir. I'm one of the group members for this group project. Today we will present our analysis on the Putra Heights gas pipeline explosion. This explosion happened in Putra Heights, Subang Jaya, Selangor, Malaysia. It's happened on 1st April 2025. This incident involved a ruptured Petronas gas pipeline, leading to a massive explosion that caused serious injuries, property damage, and widespread panic. So move on to the next presenter.
Okay, now let's talk about engineering leadership in crisis. The first one is proactive safety audits and risk management. There's a lack of regular safety audits. That Putra Heights incident showed that critical safety procedures like routine audits and subsurface mapping before excavation near high-pressure pipelines were neglected. Other than there's a controlled construction environment. There is a pre-construction safety checks are essential to guarantee that contractors operate under safe and well-documented conditions. The next one is emergency leadership, timely isolation, and crisis coordination. There's a delayed emergency response. After the pipeline rupture at 8 a.m., valve closure only occurred between 8:46 a.m. and 8:51 a.m., allowing gas to fuel the fire longer, worsening damage. There is a need for rapid isolation procedures. Leaders should have implemented and rehearsed emergency protocols, enabling field engineers to override administrative delays. The third one is clarifying accountability across contractor and operator roles. There is unplaced safety responsibilities. A major flaw was the lack of clarity regarding who was responsible for safety oversight, and Petronas claimed no responsibility outside its right of way, while contractors operated without full approval. The next is regular joint inspection. Scheduled safety inspection involving all stakeholders, operators, contractors, and local authorities can enforce compliance and uncover potential risks. And the last one is embedding engineering ethics into organization culture. Risk awareness culture. The engineering leadership must prioritize ethical responsibility, especially in populated areas, rather than focusing solely on technical compliance or cost cutting. And then there's the transparent public communication. Ethical engineering also involves explaining decisions to the public, emphasizing that safety takes precedence over rapid development. That's all. Thank you.
Next, we explore how poor communication affected public trust and safety, and what engineers can do better in future crises. One of the biggest issues during the Putra Heights explosion was the confusion about what actually caused it. Some sources blamed a contractor working nearby, while others pointed to corrosion and soil movement. This mixed messaging confused the public and damaged trust. Petronas responded slowly, and when they did, they used technical terms that many people didn't understand. At the same time, social media was full of rumors, making the situation worse. Why engineers are seen as poor communicators? Engineers often focus on being technically accurate, which is important, but the problem is they use a lot of jargon. Terms like pipeline integrity or isolation of segments are not easy for the general public to understand. Also, engineering courses don't always train us to communicate with non-technical audience. In big companies like Petronas, engineers might not be allowed to speak openly due to legal or corporate rules. This creates a stereotype that engineers are bad at communicating during crisis. Because of poor communication, fake news spread quickly, especially on Facebook, WhatsApp, and TikTok. Some people believe it was terrorism or sabotage. There were also unconfirmed reports of death. This caused panic in areas like Subang Jaya and Puchong. Without clear updates, residents didn't know if they should evacuate. Some returned home too soon or refused to leave. People got angry and started to lose trust in Petronas and the government. To improve, engineers need to simplify technical terms using examples people understand. For example, instead of saying corrosion weakened the pipeline, you can say that like how rust make holes in a water pipe. Also, companies should provide frequent updates. Even if the full investigation is not done yet, engineers should learn to use multiple platforms like social media, radio, and community outreach. It's also helpful to involve local leaders or NGOs to deliver message clearly. The biggest lesson from the Putra Heights incident is that technical skills are not enough. We also need a communication plan and trained spokespeople. In the future, engineers must not only solve problems, we must also communicate with empathy, clarity, and honesty.
Okay, the next one is standardization versus innovation. 3.1, does standardization limit innovation in engineering safety? Standard ensure basic safety, quality, and consistency. Useful for large-scale systems like pipelines. The next one, 3.2, how rigid SOP fail to address real risks. The first one, soil thermal transfer. The heat from sun or city can weaken the pipeline over the time. The second one, uncontrolled excavation. Contractor digging nearby without detection can damage pipes. The third one, urban development effects. The construction, underground water, and traffic pressure can shift or stress the pipes. 3.3, how innovation can improve safety. The IoT leak detection. For the first one, we can do the smart sensor monitor pressure, flow, and temperature. Also can send alert before failure happens. The second one, AI predictive maintenance, analyze data to predict where failure may occur. The third one, geofencing alert, create visual zone around the pipeline and also alert when unauthorized digging occur. And the last one, digital twin technology, creates a visual model of the real pipelines and also stimulates pressure, temperature, soil impact and more for better planning.
The explosion in Putra Heights deeply affected residents. As engineers, we carry a societal responsibility not just to fix technical issue, but to rebuild public trust and ensure safety for the future. First, we must communicate transparently, sharing the root cause and safety step openly through media, community talks, and social platforms will show accountability and help restore public confidence. Engineers should also improve infrastructure monitoring by using technologies like drones, pressure sensors, and performing regular inspection. This will help detect issues early and keep people feeling safe in their surroundings. It's important to meet residents face-to-face, listen to their concerns, and explain safety measures clearly. This human connection helps rebuild trust and ensure the solution we design truly meet their needs. We should also focus on youth education, such as school workshop on gas safety, how to spot leaks, and emergency actions. Community safety events or contests can also get young people involved in thinking about safer infrastructure. Lastly, giving students real-world exposure through field trips or internship allows them to see how engineering works, especially how we prioritize safety. This inspires the next generation to help build a safer, more resilient nation. In conclusion, in summary, through transparency, advanced monitoring, public engagement, and youth-focused programs, engineers can lead the way in rebuilding trust and preventing future disasters.
So to conclude our presentation today, the Putra Heights gas explosion taught us that technical compliance alone is not enough. Despite meeting pipeline standards, the disaster happened due to failures in leadership, unclear contractor, accountability, and delayed emergency action. So the key takeaways that included in our presentation today is poor risk management and lack of proactive audits that make the incident worse. Next, we have communication breakdowns where conflicting messages and technical errors will create public panic. After that, we have standard procedures fail to address dynamic risks like soil stress and third-party excavation. Last but not least, we have innovation tools like IoT, sensors, and AI that we can use to detect the risks earlier. But most importantly, engineers must now step up as ethical leaders and clear communicators. Rebuilding public trust through community engagement and safety education is essential for a safer future. So I think that's all from us. Thank you to those who are watching this video. I hope you guys can understand and learn something from this video. And that's all. Thank you very much and goodbye.